Alright, this is Ken Roosevelt. We're still on the expectation and variance videos. And here's another example from your textbook. This one won't take too long, I hope. It says, an insurance company insures a person's antique coin collection worth 20 grand for an annual premium of $300. If the company figures that the probability of the collection being stolen is 0.002 or 1/5%, what will be the company's expected profit? Well, annually they expect to get $300, right? And so let's do this. In any given year, their expectation is mu, which is the sum of the values times their probabilities. And the values that are possible are either $300 that they gain, or they lose 20 grand because they have to pay out a claim because the coin collection gets stolen. They expect this to happen, that it gets stolen 1/5%, 0.2% of the time. Okay, 0.002. So that means 99.8% of the time they expect it to be safe. So to figure out the expectation is just a simple matter of multiplication. So if we multiply that, let's see, that's going to be 299.4 maybe, I'm not sure, and then minus what's 2% of that? Well, that's 2,000. So let's go. Is that $4 maybe? I don't know. Or $40? I'm gonna guess $40. Okay. And so it looks like their expected value is 249.4. Let me just check my calculations with a calculator. Okay. So 300 times 0.998 equals 299.4. Very good. And then, whoops, 20,000 times 0.002 equals $40. And there you go. So this is that's their expected profit. In any given year, they expect to make about $250 from this policy. Okay, let's look at one more. I like this one. A lottery offers one $1,000 prize, one $500 prize, and 5 $100 prizes. 1,000 tickets are sold at $3 each. Find the expectation if a person buys one ticket. Okay, so the expectation is always the sum of the values times their probabilities. And in this case, we have 1, 2, 3, actually 4 possible outcomes. The outcomes are: you win 1,000, you win, let's see, I gotta leave room for the probabilities, right? So let me go. You win 1,000, and we'll put its probability there. You win 500, we'll put its probability there. You win 100, or you lose $3, and we'll write its probability over there. Let me just scroll over a little bit. Okay, so what's the probability of winning 1,000? Well, they sold 1,000 tickets, so you have a 1 in 1,000 chance because there's only one $1,000 prize. 1 in 1,000 is 0.001. And if you multiply those two, you get 1. Now, $500, you also have a 0.001 chance, and if you multiply those two, you get 0.5. 100, how many of those do they have? 5 $100 prizes, so your chances are 0.005. So your chance there is also 0.5. Or that product is also 0.5, I should say. And the other, let's see, how many have we used? 1, 2, 7. So the other 0.9 293 is going to be multiplied by this -3. So when we do that, we have 272721. So we have 2991, and it's negative, and it's point. So it's that. So look at this. 155, that's 2, minus 2.991 comes out to negative 0.991. So about 99 cents. Negative 99 cents is your expected value. And we'll call that approximately -1. So your expectation is, if you play this thing a lot, if you play it for the next million years, or if you buy all 1,000 tickets, you will be losing $1 on average for each ticket you buy. You will win on 7 tickets, but you'll lose on the other 993, and your winnings will average out to -$1 per ticket bought. So if you bought all 1,000, you'd actually end up losing $1,000. So for every, you can kind of think of it like this: if you lose, they gain. So if you're losing on average $1, and there's 1,000 tickets being sold, then they're gaining $1,000 on average from the sale of the tickets. Or if actually not on average, for every 1,000 tickets they sell, they're going to gain $1,000. But for you, the player who's just buying one ticket, on average, you're going to end up losing $1. Sometimes you'll win, most times you won't, and in the long run, it averages out to $1. So that's pretty much it. Those are those. The next video I'm going to do is some from Alex, now that you kind of see how this stuff is used, and that'll be it. Okay, bye-bye.